Hello guys, we are back again with trigonometry. Question 5 from a pre-trial exam. It is from the Limpopo paper. So today's question has three sections. One is 5.1. That says if 13 sine x plus 5 is equal to 0, so we write down the 13 sine x plus 5 equals 0, and tan of x is greater than 0, which means tan of x is positive. So where in the Cartesian plane is tan of x positive? Tan of x is positive here and here, and that means whatever we'll be getting from this must suit either one of this quadrant or this quadrant, which is the first quadrant or the third quadrant. Okay, so let's try and work out what can we get from 13 sine x plus 5 equals to 0. Now 13 sine x plus 5 equals to 0 can be simplified into 13 sine x equals to minus 5, and divide by 13 both sides, and we get that sine x is equals to negative 5 over 13. Now, where is sine negative? Now, sine is negative in the fourth and the third quadrant. So therefore it means the quadrant with the most ticks is the one whereby we're going to draw our right angle triangle. Now let's try and do that. Okay, so we are looking for this quadrant, and we know from SOHCAHTOA that sine is what? It's opposite over hypotenuse. So it means the opposite side is the one that is having a negative. So the opposite side for this one would be the minus 5 here, and the hypotenuse would be our 13. So we have a missing side, which is the adjacent side, but we know how to get a missing side from a right angle triangle. So we use Pythagoras theorem. X squared plus y squared is equals to r squared, and x squared is equals to r squared minus y squared, and x is equals to the square root of r squared minus y squared. And if we substitute our values here, this will give us this should give us that's 13 squared minus negative 5 squared, which is equal to a plus or a minus. Let me quickly calculate that. It's going to be 13 squared minus negative 5 squared. That gives us a plus or minus 12. So how do we get to choose? We already see that on this left side of the Cartesian plane we have, and therefore x is equal to negative 12. So our negative 12 comes in here. Now let's quickly go back to the question. What exactly was it asking? They say if 13 sine x plus 5 is equal to 0 and tan of x is greater than 0, which means it's positive, determine without the use of a calculator the value of cos 2x. Now the value of cos 2x. We should know that cos 2x can appear as cos squared x minus sine squared x, or can appear as 2 cos squared x minus 1, or as 1 minus 2 sine squared x as a double identity. Now, we already have sine from our question, so it's highly preferred that you use the identity that goes with um, what the statement of the question is given you. So therefore here we'll be going with this one. So if we say cos 2x is equal to 1 minus 2 sine squared x, this is 1 minus 2 sine x squared, of which is equal to 1 minus 2. What did we get for sine x? We got a negative 5 over 13. So it's negative 5 over 13 squared. Now this will be equal to a 1 minus 2. Now the square of minus 5 over 13 will give us a 25 over 169. Now, I know they say without the use of a calculator, but in this part, I highly advise that you use your calculator only here, because some cases of multiplication and division can be a little bit problematic, but it's highly advised for you to use a calculator here so you can get a correct answer, because some of the steps don't even give marks. So the answer here, I know we are disobeying the rule that has been given by the question, so this will be a 119 over 169. Otherwise, you'd have to do your normal fraction. Okay, let us get to the second question. 5.2. In 5.2, let me try and copy this one and paste again. Alright. In 5.2, we're given a cos 18 degrees is equal to a k. Remember we said so car tower says this is what? Cos of an angle is adjacent of a hypotenuse, so we must write this as a trig ratio first. So cos of 18 is equal to k over 1, so that we know that the adjacent is a positive value and the hypotenuse is a positive value. And they say in terms of k, so they didn't give us any specifics where cos is positive. So we're just going to go with the ordinary right angle triangle in the first quadrant, and adjacent side being k and the hypotenuse being y. Now we have a missing side, which is our y. And how can we get that? By x squared plus y squared equals to r squared. And to get y, we need to say the square root of r squared minus x squared. which is equal to the square root of, what is our r? So 1 squared minus k squared, which is equals to the square root of 1 minus k squared. Now, this is root of 1 minus k squared. Okay, that's where you get your first marks. Next up, they say determine sine 108. Before we get to sine 108, cos of 18. Now, I'd like to use my green for 18 degrees here and my yellow for, what is 19 minus 18? That will be 72. The top here. Okay, you will see why am I doing that. So for sine 108, first, what is sine 108 equal to? Now, this is acute, what's on the right angle triangle. This must be reduced to acute. How do we do that? By reduction formula. Which one? The one where sine belongs to, which is sine of 180 minus 72. And now this is a 0. Okay, and this gives us positive sine 72. Now, I always say whenever you want to read sine 72, you are going to tilt your book or device, if you're using a device or paper, such that the angle 72 faces you, and then you can see what is opposite, because we know sine is what? Opposite over. Sine is opposite over hypotenuse. Then now when you're at 72, the opposite side is k, and the hypotenuse is what? It's 1. So it means here we have a k over 1, which is equals to k. Right, let's move on to the second one, 5.2.2, cos of negative 36. Cos of negative 36. Now, cos of negative 36 comes from negative angles, which are in the fourth quadrant, and that's where cos is its home. So therefore, it's a cos of 36. Now, 36, if you look at it, doesn't belong in that right angle triangle, as you can see here. But we must remember, in grade 12, we learn about double angles. So this means this is cos of 2 times 18 degrees. And we can express that in what? As we have been given our cos. We've been given our cos 18. So must go to the identity. Remember we had 3 identities. We had cos squared. Let me rewrite them again. Double identities. When we talk of these, cos of 2x is equals to cos squared x minus sine squared x, or equals to 1 minus 2 sine squared x, or equals to 2 cos squared x minus 1. So therefore, since the question had a cos, we're going to go with this one. And let's get back to the yellow. Okay. Our cos minus 36 is a cos 36 because it falls in the same quadrant, so where negative angles are, and that's the home of cos. So which is a cos 2 times 18. So cos 2 times 18 is 2 times x, which means the double angle here. And therefore we're going to express this one as 2 cos of, cos squared x minus 1. How do we incorporate that? Okay, we now have written it in the wrong format. So you have to express it perfectly. Let me erase that of how you express it. You have to write it as 2 cos of 18, because we don't have x here. We have what? 18 as our x. Cos of 18 squared minus 1. And that'll be, what is our cos 18 equal to? It's k, so that'll be 2k squared minus 1. Okay, let's check the last one. It is a tan 738. Okay, tan 738. Or we can just paste this question again. So tan 738 degrees, that must be reduced because it's really too much. So we need to subtract 360. And if we do that, we say tan 738 minus 260, 738 minus 260, that'll be tan of 378, which is still too large, but we know that if we move from the 360, we go to 360 plus an angle in the first quadrant. So we can say this is a tan 360 plus 18, of which gives us a tan 18 as an acute angle. Well, there is another method, but I'd like to go with this one for now. Tan 360 plus an angle is found in the first quadrant, and then how do we get tan 18 from our diagram? Let us scroll back to our diagram. Tan is the opposite over adjacent. So our opposite side is root of 1 minus k squared, and our adjacent side is k. So tan of 18 will be equal to the square root of 1 minus k squared divided by k. Okay, simple as that. Right, now simplify without the use of a calculator. This is also another nice one. Let's paste the equation here so we can rewrite. Okay, the sine of x minus 180 times cos of 90 plus x plus the cos of 720 plus x times cos of x all divided by tan of 315. Okay, now how do I solve this? I use some sort of what I call toolbox. Now in this toolbox, I must resolve or put in my Cartesian plane Whatever I know is from the Cartesian plane. Already in this one, I know can factor out that into a minus 180, minus open bracket 180 minus x, which we'll write down as a 180 minus x, and we have a 90 plus x, and we have a 720. So if we go 360, but I prefer for us to say 720 minus 360. Then we get 360 plus an angle. So 360 plus an angle is here. And then angles are here. And then 360 minus an angle is there. So how do we incorporate this toolbox? Already, if you get a question like this, marks can be obtained by writing everything correctly from the toolbox. For example, I have sine x minus 180, and we know that we used to angle then variable, angle sine and variable, so rearrange that into sine of minus 180 plus x, but that doesn't look good because sine of, if we factor out negative here, 180 minus x looks like that. And sine of negative angles is what? It's a negative sine of that angle. What is that angle? That angle here is this whole batch. So most of the learners will then make a mistake there. So that's why we have a negative sine of 180 minus x. But 180 minus x belongs to sine because all students take coffee. So this is negative sine of x because in this quadrant sine is positive. So you already have your 1 mark from there. Then the second one is a, from the toolbox, is a cos of 90 plus x. Cos of 90 plus x is a cofunction. Cofunction of course is sine. Now what is the sign for cos in this quadrant? It is negative x. So we already have two, which is this one and this one, from the question itself. Then next up is a 720. I said we need to reduce that 720. We're gonna say cos of 720 plus x will be equal to cos of 720 minus 360 plus x, which becomes a cos of 360 plus x, and cos of 360 plus x will be a positive cos x. Next up is just the cos. Then lastly from our toolbox, it's our tan 315. So let's do tan here is tan 315, which can be reduced using the fourth quadrant reduction, which is what? Tan of 360 minus 45, and we get negative tan 45 because it's not the home of tan, it's what? The home of cos. So tan is negative in there, it's a foreign, and then that gives us equals to negative 1. Now we have everything from our toolbox. You're most likely to get your marks from your toolbox or once you've substituted them from the question. Now back to our question. Our question read as follows. Let me just try and paste it here. So if we have this question, I'm just gonna say equal to from there, equal to, we said this one sine x minus 180 becomes what? It's gone up. Sine x minus 180 becomes minus sine x, which was being multiplied by that cos 90 plus x changed into a minus sine x as well, and then plus that cos 720 became a positive cos of x, and then we had that cos of x all over our negative one, which is equal to sine squared x plus cos squared x divided by negative 1. And we know our first identity, that sine squared x plus cos squared x is equal to 1. Now divide that by negative 1 to get a negative 1. Okay, stay tuned for more videos that we'll be posting. Thank you for watching, and hit the subscribe and like.